Vindolanda was the largest of many military bases south of Hadrian's Wall. Once the front line of Roman Britain, this huge military complex is the most extensive ruin of its kind anywhere in Europe.
Vindolanda, a Roman fortress nestled just south of Hadrian's Wall, was constructed around 85 CE. Over 9 cycles of destruction and rebuilding, it was buried, burned, and reborn. Yet, its military history isn't what sets it apart. It's how time itself seems to behave within its buried depths, something science still cannot fully unravel. Organic materials, wood, leather, ink, even personal letters lie preserved. Pristine, after nearly 2 millennia, unrotted, unfaded, in Britain's cold, damp climate. This should be impossible. Archaeologists point to an anaerobic environment, but geophysical anomalies and dating discrepancies whisper a different story. What are these anomalies? If not oxygen deprivation, what mechanism has locked Vindolanda in a state of temporal stasis? Could this remote outpost hold secrets not just of Rome, but of time itself? A place where the past refuses to decay, defying the very laws of nature. For over half a century, excavations at Vindolanda have unearthed data that perplex even the most seasoned archaeologists' numbers, materials, and dating results that refuse to align with the orderly layers of stratigraphy. From these subtle inconsistencies, a radical hypothesis has emerged: time itself may be distorted at Vindolanda. Excavation reports from the 1970s to 1990s document persistent discrepancies, small but recurring deviations in carbon dating, wooden fragments, leather shoes, and organic artifacts from first-century layers yielded dates 3 to 5 decades younger than expected. Initially dismissed as sampling errors, these anomalies persisted even after recalibration. If modern contamination or microbial interference were to blame, the errors would be random. Yet, they cluster in the deepest, most anaerobic layers of the site. The enigma deepens with the Vindolanda tablets. Thin wooden slats inscribed with Roman soldiers' letters. Chemical analysis of their ink reveals inconsistencies. Most samples contain pure carbon, typical of Roman ink, but a few bear traces of organic binders resembling iron gall ink, a formula not widespread in Europe until the Middle Ages. Over 1,000 years later, cross-contamination during restoration seems an unlikely explanation. Stranger still, 2 tablets carved from the same wood type show different ink compositions, as if written in separate eras, yet buried together in a single layer of mud. Metal artifacts. 2. Defy explanation. Copper nails, buttons, and equipment fragments reveal alloy compositions with unusually high tin and iron content, deviating from standard Roman metallurgy, while not conclusive evidence of anachronistic technology. Metallurgists admit these compositions are difficult to reconcile with second-century techniques. Some artifacts exhibit altered structures at the microscopic level. A thin oxide layer coats their surfaces. Yet corrosion seems halted, as if oxidation itself was frozen mid-process. In 2020, data from the British Geological Survey added a new layer of intrigue. Magnetic field maps of the Hadrian's Wall region revealed a localized anomaly stretching several hundred meters directly beneath the fortress. Magnetic fluctuations here are 30% stronger than the regional average. Electronic stratigraphy equipment used in excavations has malfunctioned, with digital clocks inexplicably resetting a rare but recurring technical glitch. No one claims this is proof of unnatural phenomena, but it raises a question: could Vindolanda sit atop a natural temporal disturbance, where electromagnetic currents interact with matter to slow decay? From these scattered clues, a small group of scholars has proposed the concept of a time overlap, a phenomenon where eras converge. According to this theory, Vindolanda doesn't merely preserve materials, it preserves their temporal signatures, rather than separating archaeological layers chronologically. The site's anaerobic conditions, combined with unique magnetic and geochemical properties, may allow different timelines to intersect within the same physical space. At the molecular level, a first-century artifact might carry the temporal imprint of the second century without ever being moved. Thus, Vindolanda is no longer just an ancient fortress. It may be a temporal stasis zone, where past and present coexist in physical form. Though mainstream science remains skeptical, the dating anomalies, unusual ink traces, and magnetic disturbances remain unexplained, if these aren't errors. Vindolanda could be the first archaeological site to suggest that time may not always flow in one direction. As archaeologists scrutinized Vindolanda's scientific data, They uncovered a paradox: everything is preserved too perfectly. Defying natural processes. Dendrochronology studies from the 1990s confirmed that wooden structures from period 2 were felled around 92 CE, yet in the same soil layer. Other samples dated to 130, 150 CE, a discrepancy of up to half a century. Random errors would scatter across layers. These, however, concentrate in the site's most anaerobic core. Some geochemists suggest iron ions in the soil may have interfered with cellulose structures, skewing tree ring markers to appear younger. In other words, Vindolanda's geology itself may distort our measurements of time. This anomaly recurs in the ink of the Vindolanda tablets. A 2020 study from Durham University found that 90% of the ink samples were pure carbon, consistent with ancient Roman techniques, but 10% contained complex organic binders resembling iron gall ink, a medieval innovation. These samples, found in the deepest anaerobic layers, show almost no oxidation, their black hues vivid after 2 millennia. Molecular analysis revealed unusually high carbon-hydrogen bond ratios, a hallmark of reverse aging, instead of fading. The ink seems shielded by a chemical process that halts decay. Durham researchers dubbed this chemical stasis, a state where time itself appears slowed at the molecular level. Concurrent magnetic surveys by the British Geological Survey in 2020 detected a potent geomagnetic anomaly slicing through Hadrian's Wall, centered on Vindolanda. Fluctuations here exceed regional norms by 30%, disrupting sensors and digital clocks during excavations. Some GPS units and timers inexplicably reset, forcing researchers to overhaul their timekeeping systems. The BGS described this as a localized geomagnetic anomaly, non-artificial, ruling out human or industrial causes. In the context of the time anomaly hypothesis, this data is pivotal. A strong magnetic field could theoretically slow natural decay processes, preserving atomic structures far longer than expected. Microenvironmental data adds another layer. Vindolanda's mud contains methane and dissolved iron at 5 times the regional average. Methane stifles oxygen, while iron forms a reductive barrier, a natural sealed chamber that halts biological decay. Leather shoes retain collagen fibers. Wooden tablets maintain elasticity. Geochemists call this oxygen deprivation coupled with iron reduction, a natural form of temporal suspension that freezes chemical processes in real time. Compared to other global sites, Vindolanda is unique. Doggerland, submerged beneath the North Sea, preserves ancient DNA through anaerobic sediments. Saqqara's Egyptian necropolis maintains mummies via thermal stability, but Vindolanda combines both mechanisms, anaerobic preservation and magnetic anomalies within a single stratigraphic zone. Some researchers tentatively call this magnetogeochemical preservation, a dual process of chemical and magnetic stabilization. Though debated, the evidence suggests Vindolanda doesn't just preserve matter, it may preserve the very rhythm of time. If confirmed, Vindolanda is more than a Roman relic. It's a natural temporal stasis environment, where the past persists in physical form, and time, at least on a microscopic scale, has been slowed to a crawl. As the time anomaly hypothesis gained traction beyond archaeological circles, empirical scientists swiftly countered. To them, no phenomenon, however bizarre, lies beyond the bounds of physics. Stripped of metaphysical speculation, Vindolanda remains an extraordinarily preserved site, not a time machine. The first rebuttal targets dating errors. Carbon-14 dating is not infallible. Early measurements at Vindolanda in the 1970s and 1980s used semi-automated equipment with a margin of error of plus at 40 years, precisely the discrepancy cited by time anomaly proponents. Moreover, samples were taken from methane and iron-rich wet soil, where external carbon absorption is ongoing. Experts from the British Museum argue that free carbon molecules from methane likely infiltrated wood fibers, skewing dates to appear younger. When retested using dendrochronology, a more precise tree ring method, all dates aligned with the expected 1st to 2nd century timeline. No timelines are warped, wrote Dr. Andrew Burley in a 1997 report. These are merely measurement errors within acceptable margins. The anomalous alloys also faced scrutiny. A 2018 find, a bronze hand near the northern gate, was briefly misreported as a titanium-aluminum alloy by online communities. Spectroscopic analysis later confirmed its composition 87% copper, 11% tin, and under 1% iron standard for Roman artifacts. The advanced alloy rumor stemmed from a misinterpreted preliminary report mentioning metallic residue, which a blogger exaggerated into an unidentified alloy. Full testing reclassified the object as a ceremonial item, with no ties to modern materials. The magnetic anomaly theory meets similar skepticism. The British Geological Survey never endorsed claims of a time rift or magnetic resonance anomaly. Their 2020 data, often cited by fringe sources, merely mapped natural geomagnetic variations in Northumberland's ferromagnetic basalt, well within normal ranges. These fluctuations may cause minor sensor errors, but cannot alter physical decay or time itself. There is no temporal field at Vindolanda, only a slightly stronger than average magnetic zone. The reverse aging ink also has a mundane explanation. Conservators at Durham admit that some Vindolanda tablets were treated with iron-based preservation solutions, which produced iron gall-like signatures in Raman spectroscopy. Roman carbon ink is inherently durable. In anaerobic conditions, it resists oxidation, making chemical stasis a byproduct of the sealed environment, not evidence of frozen time. Collectively, mainstream archaeologists conclude that Vindolanda obeys natural laws, optimized for preservation. Carbon errors are correctable, strange alloys are ordinary bronze, magnetic fluctuations are geological norms, ink anomalies stem from conservation chemicals. No evidence supports a temporal anomaly. Yet, a psychological factor persists when artifacts are preserved beyond comprehension. Humans seek extraordinary explanations to bridge the cognitive gap. Vindolanda, in the scientific view, is a miracle of preservation, a triumph of nature. Not time. But one question lingers: why do these small errors appear only at Vindolanda, and nowhere else along Hadrian's wall? After decades of debate, a new theory emerges neither as radical as time travel, nor as rigid as conventional archaeology, dubbed the chronopreservation field. It posits Vindolanda as a natural environment where geological, magnetic, and acoustic factors converge to slow material decay, akin to cold preservation in molecular biology. Geophysical data reveals that Northumberland, where Vindolanda lies, sits atop ancient basaltic rock rich in magnetite and hematite minerals that generate a weak but stable magnetic field. When this rock interacts with methane and iron-rich anaerobic mud, it may produce minute electrical currents, resembling natural electrochemical cells. This weak electromagnetic field cannot affect living organisms but could slow oxidation reactions, preserving organic materials at a fraction of their normal decay rate, a form of molecular freezing without low temperatures. Another factor is Vindolanda's acoustic structure. 3D analysis shows parallel walls and stone hollows that resonate at low frequencies 10 to 20 Hz when wind passes through. This infrasound stabilizes microclimates, minimizing humidity fluctuations across layers. Such low vibration environments maintain thermal-chemical equilibrium, akin to laboratory conditions for preserving biological samples. Together, these elements, geomagnetic, electrochemical, and acoustic, form a natural resonance system. No portals or time loops exist here, only a rare balance of energy, humidity, and chemistry. Time doesn't stop, but its progression slows to an imperceptible crawl, unmeasurable by standard decay cycles, if valid. This theory makes Vindolanda extraordinary without invoking the supernatural. A Roman fortress, built by chance at the precise intersection of geology, magnetism, and architecture, becomes a natural laboratory of stasis where the past endures not because it was revived, but because it never left. Vindolanda holds no quantum rifts or temporal gateways. Yet, in archaeological terms, it remains a natural time machine. Step into its depths, and the past appears as if it never faded. Leather shoes, wooden tablets, ink, and letters endure in near-pristine condition after 2,000 years. Vindolanda doesn't just preserve objects, it seems to preserve moments. It functions as an archaeological time lock, where decay slows to near zero. The past isn't resurrected, it simply hasn't departed. Geophysical models suggest Vindolanda is a natural apparatus, where geology, magnetism, and moisture create a temporal stasis effect. No magic, just a convergence of physical forces. If Vindolanda is a time stasis point, one question remains: could other fortresses along Hadrian's wall, hidden beneath forests, mud, or stone, also hold time in suspension? Perhaps, to find the past, we don't need to reverse time, only to find the places where it never moved.